All right, everybody. Today we are going to talk about solving equations. This is going to be part 1. So the reason that we're going to call this part 1 is today you'll notice that when we solve equations, and why is it an equation now? Well, we have an equal to sign. So remember before we kept talking about these are expressions, and whenever y'all wanted to try to solve for x, we said, no, hold on. We combine like terms to simplify expressions. We solve equations, and we know the difference is because equations bring in this equal to sign. So today we're going to focus on opposite operations. Adding and subtracting are opposite operations. They undo each other, just like multiplying and dividing undo each other. So kind of having that in our mind as we get going. Entering into the world of solving equations, this is an exciting day. We're going to solve each equation for the given variable. So remember, variable just means the letter, the unknown. And so for each of these, we have to start with the unknown is x. So what we want to do here, which we want to have in the front of our mind, is we want to get the variable alone. So to try to use the common language here, we're going to refer to it as isolating. So isolate the variable, aka get the variable by itself. So when we look at number 1, in order to get the variable by itself, and we might even want to circle it or box it or highlight it, we want to get that x alone. So anything that's happening to x, we want to get rid of it. We want to undo it because we need to get x all by itself. So for number 1, if we're looking at an equation, again, equal to sign, and we're solving for the value of the variable, the unknown, I'm asking myself, okay, to get x by itself, what's happening? So to begin, what are we even doing to x to start with? Well, for this equation, we are adding 4. We're increasing x by 4. So in order to solve for x, we actually want to think of it in terms of doing the opposite. So the opposite of adding 4 would be to subtract 4. So in order to get x by itself, I'm going to come down here and think, okay, I want to undo the addition of 4. I do that by subtracting 4. But one thing that we're going to see is when you have equations, when you have an equal to sign, we've got to balance our equations. So what I do on one side of the equal to sign, I need to do on the other. So I can't just subtract 4 over here without balancing and coming over always across my equal to sign and doing the exact same thing. That way, I'm not just randomly getting rid of something, I'm moving it. On the left, I'm making this go to 0. So if you think about positive 4 and then taking away 4, if you take away the only 4 you have, on this side, this just zeroes out. Kind of think of that as a z for 0. I'm zeroing that plus 4 out. I'm left with just an x. I don't need to write plus 0 because that doesn't change anything for me. So think about it like plus 4 minus 4, cancel that out. And then now I have to simplify this. So this is where you'll go to Desmos or use your phone calculator or whatever calculator, if you have a handheld, whatever you have. And we're going to check so that we don't make any silly mistakes with our signs. We're going to simplify negative 2 minus 4. So negative 2 minus 4 is a negative 6. And so that is our value of x. We got x alone by doing opposite operations. Once you solve for x, you can box them up, and that's our final answer. Now, to check, and you don't always have to do this, but you might want to check, we could plug it back in, right? So if we have x plus 4 equals 2, and I want to see, hey, did I do this one right? I can replace x with that answer that I just got. So I solved it, and I think that the answer is negative 6. So if I now check negative 6 plus 4 in the calculator, oh, I did a silly mistake here. Watch out, Miss Sandoval. Got to bring that negative, right? Copy the problem, right? So when I add that, 6 is negative, and it's a bigger number, so my answer comes out negative. This should check out. So as a quick little check, you can always throw it in the calculator, plug it back in, and just make sure that you're getting what you would expect for this equation to be balanced. Now looking at number 2, here we have x divided by 5, and that is equal to -4. So I want to see what is the value of x. So I'm going to rewrite this just so that when you look at it again in the future, or if you're copying your notes down with me here, that you have it kind of like a clean version, so to speak. So remember, we're trying to isolate the variable. We want to get x alone. So ask yourself, guys, what is happening to x here? Because I know I want to do the opposite to get x by itself. So if I have x being divided by 5, then I need to ask myself, well, what's the opposite of dividing? Well, we know that multiplying and dividing are pairs. So to undo dividing by 5, what I'm going to do is actually multiply, and of course the only pens in front of me right now are all blue, but what I'm actually going to do, choose a black pen here, is multiply both sides by 5. So I have dividing by 5, so let me do multiplying by 5. When we do that, multiplying and dividing by 5, they cancel each other out because they're opposites, and that just leaves me with the x. So now the x is alone on the left, and then over here, that dot's telling me to multiply, so -4 times 5, or you can even put parentheses if you want, gives us a -20. And then as a check, I could take -20, divide it by 5, and make sure that I get -4. And when you do that, you will see that that one does check out, so that's perfect. Now, example 3, there's a little more going on here. So I want to isolate the variable. So I'm trying to solve for x. But first, I want to see, always ask yourself, can you combine like terms? These were so simple that at the beginning on each side, we didn't have like terms, right? We still don't have like terms, but we do have subtraction and multiplication happening to x. So we're subtracting 2 and multiplying x by 5. Just as a good rule of thumb, to get x alone, anytime there's anything added or subtracted, move that first. Okay, so order of operations, move any added or subtracted terms first. So what that's going to look like for us is we want to undo this subtracting 2. So just like up here, we had +4, so we did the opposite, which was subtract 4. If I'm subtracting 2, then the opposite is going to be to add 2. But balancing my equation, what I do on one side of the equal to sign, I have to do that same thing on the other. So if I'm subtracting 2, I add 2 to cancel that out and zero that out. So now -2 plus 2 is 0. On the left, the only thing that's remaining for me is that 5x. So I bring that down. Checking this guy in the calculator, -32 plus 2. That is a -30. And so after we're here, now we're back to asking ourselves again, I'm trying to get x alone. What's the opposite of whatever's happening to x right now? So now x is being multiplied by 5. So the opposite of multiplying x by 5 is going to be to divide x by 5. And what we do on one side of the equal to sign, the equation, we have to do it on the other to balance it. Now 5 divided by 5, just like over here, we're dividing by 5, we multiply by 5, it cancels. Just like the same idea, it's going to reduce out. 5 divided by 5 cancels or reduces, leaving us just with the x, which is what we were after. And then reducing here, negative 30 over or divided by 5 gives us a negative 6. And so it's just a coincidence that we got negative 6 again. It's not like all of our answers don't have to be negative, but that would be our solution here, negative 6. And as a check, you can always plug it back in, do 5 times negative 6, and then minus 2, and make sure that that checks out and gives you negative 32. And then the last one we're going to do for this part of the video is going to be number 4. So number 4 gets a little uglier, right? So we do have some decimals here. It's going to be all right, though. We are going to follow the same process. Get that x alone. I want to isolate the x. Always move what's added or subtracted first. So looking at this, I can't combine like terms because they don't both have an x. So my next step is to get the variable by itself. I want to undo that subtraction. So the opposite of subtracting 1.24 is going to be to add 1.24. My bad, I put a plus, so what I do on one side, I want to do the same thing on the other, so I'm going to add 1.24, careful, right? So when I do that, negative 1.24 and positive 1.24, I'm going to zero that one out, and that's going to leave me with this 1/5, that's what we have here, 1/5, and then our x term is written behind it. So it's like the coefficient on the x is 1/5. Now I'm going to add 9.56, and so I'm going to do plus 1.24. So 9.56 plus 1.24. I just did that on my phone real quick, and I got 10.8. Once you're here, we then want to ask ourselves, okay, I need to get this x alone. So right now, what we're seeing is we're multiplying 1/5 times x. So this isn't going to be the prettiest, but the calculator can do the legwork for us here. To get x alone, so I'm trying to isolate x, I want to do the opposite of multiplying by 1/5. That can look like dividing by 1/5. Not pretty, right? I know, it's okay. Dividing by 1/5. So these 1/5 are going to reduce out, and that's going to leave us just with the x. Anytime you divide, it doesn't matter how ugly it is. When you divide something by itself, the answer is going to be 1. It's going to reduce to a 1. So remember, we talked about there's that little 1 that's in front of x, that coefficient that we aren't writing. Now put this in the calculator. I'm not going to switch to Desmos just yet because the way I'm recording this video, I told it just to record my screen here, so I'm afraid if I switch out, I'm going to lose you guys. But in the calculator, and I'll show you all in class, and I'll show you in the calculator for future ones, 10.8 divided by the fraction 1/5. When you do that, you will see, let the calculator do the work, that you get 54. So from here, that is our answer. We have 54. We don't have to do anything else at this point. It's simplified. You could plug it in here as a check. Take 1/5 of 54, subtract 1.24 from it, and you should see that it checks out to give us that answer we're looking for. So that's going to be our part 1. And if you need to listen to any of this again, please do. I'm going to come back and do a video for problems 5 through 7.